record structures. Defining the record structure is the first of many steps in the process to use record structures. The record structure section with the various topics will cover defining the record structure and all of the other steps to show how to use them. An overall look of the process to work with record structures includes to first define what kind of information will be stored in memory. The definition will identify the specific items in any lists of values. We will define the record structure using the record command. Next, we will tell the system how much memory is needed to store the data. We will allocate or initialize memory for lists. Many record structure definitions are set up in a way that memory is not pre-allocated. With these types of definitions, there are commands we use to allocate or initialize memory for these lists. Many times, the data to be placed in the record structure is coming from the result of a query. In that case, the amount of memory isn't readily known. Often, a dynamic process is used to determine if memory is available or needs to be allocated before storing values in the record. We will review a process that allocates memory in blocks and adds more memory as needed. Store values to record items. After space in memory is allocated, we place values in the record structures by assigning values to positions in the record structure. Once data is loaded into memory, we can use the stored values later in the program. We will practice displaying values from the record structure, show how we can use the values in the record structure as qualifications. We will read additional tables to get related information. We will practice how to get information from other Millennium tables that are related to items stored in the record structure. Conceptually, a way of linking record structures to tables. Let's work our way through the process of working with record structures by first looking at the record command to define the record structure. Defining record structures. The record structure definition tells the system what type of information you want to store in memory. To define a record structure, first, use the reserved word record, followed by the record name, which is user-defined. You could have a record structure whose name is Inc. Or maybe you have a record structure called person.ord.rs or aliases.rs. Name your record structure whatever makes sense to you for what you are storing. Within the open and closing parentheses, define all items to be stored in the record structure, which includes lists and specific items. A list might be a list of orders or a list of people. You define specific items, such as a person's name, age, gender, as part of a list or outside of a list. All items to be stored in this structure must get defined. To start defining the lists and items, the definition starts with a level. The level represents a hierarchy. A level 2 is dependent on a level 1. A level 3 is dependent on a level 2, and so on. The levels are used to create dependencies, such as creating a list of order information at level 2 that belongs to a person's specific encounter visit at level 1. In this record structure called person.ord.rs, an encounter visit is defined at level 1 along with its order list. The order information for the encounter are assigned to level 2. We will review many more examples of levels and how they are used to create the hierarchical dependency. Let's talk more about lists and how they are defined. You may want to store a list of items. For example, maybe you're going to store a list of orders like the orders list that is in the person ord RS record structure. Lists can be defined as standalone, independent lists, or the list can be nested. To establish a list, the list is assigned an appropriate level and then provided a user-defined list name, such as orders list. Within the square brackets, place a number representing how many items are to be stored in the list. Typically, we do not know the number because the data is coming from a query. In those cases, we place an asterisk in the square brackets, just like in the orders list of the person ord RS example. We don't know how many orders there are for the specific encounter at the point the definition is created, so an asterisk is placed in the square brackets. Later in the program, after the query runs, we can allocate space for the lists and adjust the size as needed. We will review a dynamic process for allocating space in the record structure to accommodate for the unknown amount of data from the query. Basically, the process allocates space in blocks and adjusts the size as needed. Next is to define the actual data to be stored in memory. The data you want to store in the record structure may be a part of a list or independent of the list. Each defined item first gets assigned to the appropriate level. If the item is part of a list, it will get a level number lower than the level assigned to the list name. If a list is at level 1, then that list's items will be assigned to level 2. The item is provided a user-defined name and is set equal to a valid data type such as VC, F8, DQ8, or any other valid data types, just like the order mnemonic in the person ord's RS definition. The orders list is at level 1. The order mnemonic is a part of that list and is assigned at level 2 to show its relationship to the list. Order mnemonic is the assigned user-defined name, and it is set equal to a VC data type. If there is more information to be stored in memory, you continue defining lists and items until everything has been listed in the definition. Notice at the end of the definition, you could add a with clause to add a scoping option to control when the definition is known or not known during processing. By default, the record structure definition is public. However, you could change the scope to private, protect, private protect, or persist script. A command that can be used for processing with record structures is the free record command. The free record command can be used to remove a record structure definition and deallocate all memory during a program's execution. The syntax shows using the free record and passing in the record name person ord RS. The free record command should be used sparingly and strategically only when it's needed. After a program that uses a record structure finishes, the record structure definition is cleaned up and completely removed by an automatic cleanup process. Because the cleanup is automatic, the free record command is not needed before the record command and is not necessary to use when the program is done. The free record does use resources, so used unintentionally uses unnecessary resources. So, what is the recommended use of free record? This command isn't needed all that often. A scenario where it might be useful is if you have a complex process where you need to reestablish as much memory as possible for further processing. Let's say you have a program that uses a record structure, and after it is used, the program has much more processing to get through. You could free the record to give the process back the memory for other processing. Using the free record in this case might be a good idea. If there's not a specific intended use for the free record, like freeing memory during processing, then this command should not be used. You do not want to unintentionally use the free record and accidentally wipe out a definition that's needed. The initrec is another command that is available, but like the free record command, it is not needed too often. Initrec is used to keep the definition but deallocate the memory. If a program is midway through processing and there is a memory overload concern and a need to reuse the record definition, the initrec can be used to keep the definition but give back the memory to the process. When a program finishes executing, the record structure definition is removed, but while the program is still executing, the record structure definition can be made available for other processes associated to the executing program. The initrec command is a faster process than the free record command. The syntax shows initrec by using set stat equal to initrec and passing in the record name, person ord rs. Let's review some syntax examples of using the record command to define record structures. The following is an example of a record structure definition that stores information at one level. It is a record structure called Inc. Within the parentheses, we see 4 items at level 1. It looks like it's storing one encounter ID that has an F8 data type, one nursing unit that has a C40 data type, one room and one bed also defined as a C40. Once this record structure is populated, think about it as one row of data. Encounter ID 3458 is in a pediatric nursing unit in a room called PEDS 4 in Bed A. Maybe this is information being passed from a front-end application, like a reply structure. A Discern Explorer program is executed and accepts the information from the record structure. A query gathers information related to that encounter and creates a report that displays diet orders, a list of medications, and other pertinent information. This next definition is storing a list of encounter IDs and types. It is a record structure called INCS. At level 1, there is a user-defined list called qual. A quick side note about the list name qual. You may find many scripts with a list name of qual. Qual, although not that descriptive of a list name, is commonly used. Its heavy usage is simply due to the copy factor. When a new program is created, instead of starting a new script from scratch, a portion or a copy of another script is used as a base. Since many templates or base scripts have defined record structures with list names of qual, the list name proliferates through to many scripts. As a reminder, list names are user-defined and should be descriptive if possible. Now let's get back to the definition. The number of encounters in the qual list is unknown and will be figured out when the query runs, so the asterisk is placed as the dimension. Level 2 is used to define 2 items that belong to the qual list. So for each encounter, it will store its ID and corresponding type. Once this record structure is populated, conceptually think about it as a list of encounter IDs and their encounter types. The first position in the qual list is storing encounter ID 3458, which has an inpatient encounter type. The second position in the qual list is storing encounter ID 3502, which has an outpatient encounter type. And the next 3 positions in the qual list that store their encounter ID and their respective encounter types. Although qual is common, since the list name is user-defined, maybe a good list name in this example would be IncLists. Using a descriptive list name is helpful to keep the record structure definition readable. Let's move on to the next definition. Let's look at defining a record structure that has lists at the same level. This is a record structure called person ord stat. It contains 3 independent lists at one level: a canceled, completed, and future orders list. The number of orders to be stored in each of the lists are unknown, so an asterisk is used in the square brackets. Within each of the lists, it's storing 2 items: a catalog code with an F8 data type and its respective catalog code display that has a C40 data type. When the record structure is populated, conceptually, think of it as 3 individual lists. The canceled list has 3 orders stored in memory. The completed orders list has 6 orders stored, and the future orders list has 2 orders stored in memory. The definition provided a way to have 3 lists of information that are not necessarily related to each other. Let's look at one more definition that shows nested lists. This next record structure definition shows parent-child lists at different levels. This definition shows a record structure called temp1. Level 1 has a person ID defined as an F8 data type and their respective name with a VC data type. Also at level 1 is a list called orders. We know it is a list because of the square brackets. Since there is an asterisk for the dimension, the number of orders for this person is unknown at this time. We will figure out the number of orders after the query runs. The orders list is the parent list and is associated to the person. The items to be stored in the orders list are defined at level 2 and are comprised of the order ID, which is an F8 data type, and the order mnemonic with a VC data type. Also at level 2 is a defined DTAs list. This DTA, or discrete task assay list, is a child list associated to the specific order. With this list defined, each order can have their own list of procedures. We don't know how many procedures each order has, so an asterisk is used in the square brackets. The items in the DTA lists are defined at level 3 to show the relationship to the DTA list. The list will store the result ID that is equal to an F8 data type and the procedure name, which is a VC data type. So, one person can have multiple orders, and each order can have multiple DTAs. When the record structure is populated with this type of definition, conceptually, think of related data with a child list and its association to its parent. Once populated, this record structure contains information for Bill. Bill has 3 orders: a lipid, a CBC, and a lights. These orders are in the orders list, listed in position 1, 2, and 3. Each order has their own DTA list. Lipid has 3 procedures in its DTA list. CBC has 2 procedures listed in its DTAs list. And the lights orderable has 4 procedures listed in its own DTAs list. The list associated to a specific order can have its unique number of procedures for its list. Nested lists can have varying length lists, such as this example, where the lipid order has 3 DTAs in its list, the CBC has 2 DTAs, and the lights order has 4 procedures in its list. Now, one last thought. What if we wanted the record structure definition to store multiple people, their orders, and DTAs, instead of just one person? How would the record structure definition change to accommodate multiple people? Was your idea to push the levels down by 1 and create a person list? This is a great idea. Let's see what that looks like. A person list was added at level 1 called plist. All of the original items got bumped down a level. Now, person-level information, person ID, name, and the orders list are at level 2. Order information and the DTAs lists are stored at level 3. And the actual DTAs are stored at level 4. With this definition, we can store multiple people, people can have multiple orders, and each order can have multiple DTAs. This is the end of our discussion about how to define a record structure.